My dear friends, welcome to Raja SEKAR classes on applied data science with Python. This is lecture number 70. In this lecture, we will try to understand mean and median with simple demonstration. Let me go to Jupyter Notebook. If you observe this one, import numpy as np. These libraries I need not explain again and again. Just see here what I am doing. Read underscore CSV. This particular command or function we discussed many times, isn't it? In my system, in E drive, there is a folder applied data science with Python. In this particular folder, I have a file whose file name is 500 underscore person underscore gender underscore height underscore weight underscore index.csv. This particular file I downloaded from Kaggle database or Kaggle website. Just go to Kaggle website where you can find it's freely downloadable file. If you have an issue, just keep a comment so that I will try to answer. Now anyway, your data frame is in an object known as height underscore weight underscore data. This is my data frame, simply I can say. Therefore, height underscore weight underscore data dot head 5 means what? It will display first 5 rows. This is not new thing. We discussed many times. For my calculations, means to calculate mean and median, I don't want this index column. In that case, what I can do? Height underscore weight underscore data. This is my data frame name. Drop. I am dropping. Which one I am dropping? Index column. This particular index column I am dropping. In place equal to true means that changes will get affected or reflected in height underscore weight underscore data frame itself. Axis equal to 1 we know. What is axis equal to 1? What is axis equal to 0? We have spent lot of time, isn't it? That particular column will be dropped in simple manner. I can say that column is dropped and that changes will reflected back in height underscore weight underscore data. Now let me check whether it is dropped or not. Height underscore weight underscore data dot shape. Shape means you are getting 3. Means there are 500 rows and 3 columns. Initially there were 4 columns: gender, height, weight, index. Now index is removed. Therefore you have 3 columns. Successfully we removed that particular column. What about this is null? You can check the missing values in the data set or data frame using isNull function. isNull.sum will give you count of missing values. This also I discussed many times in my previous lectures. Just go through my previous lectures, you can understand. Just see, gender is a column, it's 0 means there are no null values. Height is a column, 0 means there are no null values. Weight is a column, 0 means there are no null values. What does it mean? This is fairly a clean data set. No missing values at all. Every column in the pandas data frame can be treated as series object. What is a series object? We will try to understand. Just see. I can say like this. You can access particular column and invoke specific function to give you statistics on the column. Anyway, how will it be? We will try to analyze. Just see. Anyway, height underscore weight underscore data is my data frame name. There is a column named weight. That column values I am collecting in a variable known as weight. In this variable I am collecting all the values present in this particular column. Weight.head means what? It will give first to 5 values of that weight column. 96, 87, something like this, isn't it? It's not great thing. Now we will try to understand. Here there is something like what can I say? Let me say like this. There is something like weight dot sort underscore values. Means this weight holds all the weights in my data set. Let me go back and let me explain first this one. Just see, this is weight. Yes, this weight holds all the weights in my data set. If you want to manually calculate the median of a data set, you will need to arrange that data in the sorted order. Why? Because to calculate median, we must arrange elements in sorted order. That's what I discussed in my previous lecture. I am going to use the sort value function to get all the weights in sorted ascending order. That's what it says. Here I am applying sort underscore values. Means weight I already explained. Just see, just go back weight. This is weight, in which you have weight column values, which is present. This particular column is present in height underscore weight underscore data, isn't it? Anyway, maybe I am explaining same thing many times. Now, sort underscore values, it will sort reset underscore index drop equal to true means what does it mean? It drops the current index of the data frame and replaces with index of increasing integers. It never drops columns, isn't it? It's not big thing. You can understand that this sort underscore weight, you can have what you can have. You can have all sorted values. This one is same. Actually, this sort underscore weight, I copied twice maybe. Let me remove this one so that you will get clarity. Just see, sort underscore weight equal to weight dot sort underscore values reset underscore index drop equal true. What does it mean? What I did, I collected all the values of weight column. Dot sorted underscore values means we are sorting, and reset underscore index equal drop means I already explained it drops the current index, isn't it? Therefore, and it keeps index as an increasing of integer 0, 1, 2, 3, 4. Just it is an increasing of integers. It's an index. Simply you can say you are sorting elements and keeping in sorted underscore weight. This mean function I already explained in lecture number, I think 67. Just go through that lecture. I think I need not repeat that explanation. We already discussed what is mean. Now we will try to understand median, isn't it? Median, this function assumes that elements that are passed are sorted order, isn't it? In theory, in previous lecture also we were saying that elements must be in sorted order. This function will means how can I say, I'm going to get the total number of elements present in my data. What is this? This is median, is a function which is we defined our own function instead of using predefined function def space function name median data, isn't it? I'm going to get the total number of elements present in my data. How can I get? Len of data. If I say len of data means I will get total number of elements. If this total number of elements modulo division 2 equals 0 means what? I will see whether we have an even number of elements. When can I say it is having even number of elements? If number of elements modulo 2 is equal to 0, then I can say it is having even number of elements. That we have an even number of elements. I will calculate middle point between the middle two elements of my data. If you have an odd number of elements, then I will return the data point exactly at the center as my median. I already discussed this theoretical concept in previous lecture, isn't it? What you have to do, if you have even number of elements, what you have to do? If you have odd number of elements, it's straightforward. If you have odd number of elements, just it's a matter of middlemost element. If it's having even number of elements, you have to take average of middlemost two elements. That's what this formula says. Now what I have to this is simple definition. Invoke first I will invoke my mean function. I already explained this mean function in previous lectures, but with a different data file. Anyway, let me repeat this one. Mean height underscore weight underscore data. This is my data frame name. This is weight is column name of my data frame name. Just let me run. What I am getting? I am getting 106. Number of elements 500. Sum is 5000. This I already explained in previous lectures only. I think I need not repeat. You may feel a little bit bored if I explain again and again. Again, what it says, even you can calculate mean by using predefined built-in functions which can be applied on pandas. Dot mean also. This is built-in one. You can this is 106. This is user defined. We only defined. This one is built-in on pandas. This you are getting same result, whether it is built-in function on pandas, whether it is user defined function, you are getting same mean. In similar manner, let me find median. How can I find median? median of height underscore weight underscore data of weight. What does it mean? You are getting some number 79.5. Is it correct one? The median says 79.5, but this is actually wrong because I have not passed in the median in the form of sorted values. In simple manner, let me simplify. This weighted is unsorted. This is not in sorted manner. With the unsorted array you are passing. In that case, it will calculate median for the unsorted array. This 79.5 is not correct. Therefore, I already sorted this one. Just I stored in a separate variable name. Just go back and check. Just see, this one is sorted underscore weight, where I can store the sorted weight values. Now, if you apply this median on sorted underscore weight, you will get correct median value. Therefore, 106 is correct. 79.5 is not correct. Why? Because you are passing unsorted elements. Therefore, it is giving wrong result. In this case, you are getting mean and median are same. This 106.0, here also you are getting 100. They are same, isn't it? Anyway, let me try to visualize this one. This one I already discussed in my previous lecture. How can I plot figure? I already discussed what is import numpy as and this the plt dot figure. These things I discussed. 12,8 means in that class we were saying that 12 inch width, 12 inches width, 8 inches height of this figure size, isn't it? Height underscore weight for weight hist means histogram, isn't it? Bins equal 30 means I am going to divide weights into 30 bins and heights of the bars will indicate count of the data points in each bin. This also I discussed, isn't it? plt.axv line means what? I am going to draw vertical line on this histogram visualization to indicate whether average of data line, where is that average. Let me run this one so that you can understand. Just see this figure. Maybe it may be little bit big. Let me reduce size so that it may be little bit clean and clearer. Just see this figure. This is the histogram. Just see mean. This what is that red color one? This is known as legend. This legend I discussed many times in my previous lectures, isn't it? Just see, this is mean. This is mean. This, if you observe carefully this distribution, it is not following. How can I say? If you observe that real world weight follows. This is the data of weights. Real world weights data follows normal distribution, but here this is not following normal distribution. Why? Because we have collected only few records. 500 records means there are only few records, so that it's not showing normal distribution. Usually your weights data follows normal distribution. This one is your mean, this one is your legend. We discussed a lot on histograms in previous lectures in data visualization classes. Just go through that, you can understand. Yes, again this one is also same. For previous one we were building, we prepared or we executed this one for mean. Now we will try to execute same for median, isn't it? This is for median. Just see what it says. PLT height underscore weight underscore data hits bin. For which one? AXV line. This is weight underscore median. Means in this case median and mean are same. That you must remember. Both are 106 only, isn't it? Both median, just see, this is median, isn't it? Median and mean is same. Therefore it looks like same, isn't it? Just go through this code, just understand this code. This code is very simple, just like previous code. In my next lecture, I will discuss few more points on mean and median, so that so that we will try to understand after that other measures of central tendency. Thank you very much.